Hi, this is Tutor Think. In this video, we are working on the Laplace transform for e to the power minus at. There is an introduction to Laplace transform in this playlist. You can locate that. And then I have worked on a video for Laplace transform for f of t equal to e to the power at. So in this one, we are just taking the same function, but we are working on the negative part of this. So let's start. We learned in those previous videos that the Laplace transform of a function is given by the Laplace transform of f of t being equal to the integral from 0 up to infinity f of t times e to the power negative st dt. So we are all familiar with this. All right, so we have f of t equal to e to exponent negative at. So all we need to do is to substitute that here, and we substitute that here. So we have our Laplace transform of e to minus at. Remember that a here is a scalar, okay? It can be any number, okay? So we equate this to the integral of 0 to infinity, and then we substitute our f of t, which is already this. So we have e to negative at times e to negative st dt. All right, so in the next step, we are gonna use indices to work on these two powers. But before that, because I'll be working on the powers, usually I want to break my solutions down for those of us that have issues to really understand. So for those of you that are very smart about these things, please pardon me for this one. So I'm just interchanging the position of this and this so that I can work on the power for you to get the concept easily. Okay, so this is the same as 0 to infinity e to the power minus st times e to the power minus at dt. Okay, it's still the same. 2 times 3 is the same as 3 times 2. Okay, so multiplication is commutative. This is my multiplication sign. All right, so now we pick one of these base and we work on the powers. Okay, so in our next step, we have integral of 0 to infinity. Now I'll pick one of the base, then I'll factorize t. So I'll write my s plus a times t, then I'll bring my negative out. Remember that this is negative, this is negative. If I use this to multiply this, I'll have minus s times this will give me minus st, and this time this will give me minus a times the t will give me minus 80. So we are okay. So this times dt. Don't forget that this is the first derivative of t, where t here is a real number that is between 0 to what? Infinity. So it must be greater or equal to 0. Now we also know that s here is the imaginary part. Remember that it is a constant that must be large enough for the product of this and this to convert to 0 as t approaches what? Infinity. I don't want to explain this here because I've done all these things in the first video. So now when we get here, the next step is to integrate this function and introduce our limit. Okay, so if I have an exponential function such as e to the power, let's say at, then the integral of this is 1 over a e to the power of 80. Or you can also say it's the same as e over a 80. Remember that this side is over 1. So when I multiply 1 times a, I'll get this. 1 times e to the power 80, I'll get this. So it's the same thing. So let's assume if we have something like e to the power, let's say minus 2t, then the integral of this is going to give us 1 over negative 2 e to the power minus 2t. Or the same as e minus 2t over negative 2. Okay, so now let's apply that here. Now we have negative into s plus a. Okay, so that is what we will use. Everything here is representing the variable what? A, that I use as an example. Now let's integrate this. We use everything here, 1 over everything we have here. So 1 over negative s plus a. Remember, we don't add this t because this side is the coefficient of t, okay? So we raise to the same power e minus s plus a, okay, times t. Now I will introduce my lower and my upper limit. So by putting this side in bracket, 0 and then my infinity. Alright, so like I said earlier, I do not want to represent the limit by a constant or a variable and then approach it to infinity, okay? So let's just cut off some method and move straight. So I'll just substitute the upper and lower limit into the question and then we complete the calculation. So from here, your next step is to substitute upper limit first minus the lower limit. This is your upper limit, this is your lower limit. So we have a negative 1 over s plus a times, now let's put in our upper limit. Now remember that 0 to infinity are the values of what? T. Like I said earlier, t is a real number that is between 0 to infinity, or t must be greater or equal to 0. So these values are for t, so we put it there. We have e minus s plus a, then we substitute our upper limit, we close the bracket, minus, we substitute our lower limit, e minus s plus a, then we put in our 0, we close the bracket. Now the next step, before I continue, let's talk about this. If I have the limit of, let's say, e to the power negative x, where x approaches infinity, then the result of this is equal to 0. So anytime we substitute a large number for x, the result will converge to what? 0. So infinity is a very large number. We don't know the number, okay? So from this approach, we can say that when we take the limit of this, the result will converge to 0, because as t approaches infinity, the whole result is what? 0. If you substitute a very large number here, the result will convert to 0. Now for this side, we know that when we raise a variable to the power 0, the result is 1. So this side, we know we are having what? 1. So now this result becomes negative 1 over s plus a times, now this side is 0, so we have our 0, and this side is 1 minus what? 1. Now in our next step, we use this to open bracket. This will multiply 0. The result is 0. We are not interested in that. Then this times this is what we are looking for. So negative this times negative 1. The result is giving us 1 over s plus a. So now the Laplace transform of e to the power negative at is giving you 1 over s plus a. So now a negative here will make this side positive. A positive here will make this side negative. So you locate these two videos. I've done the first one for the positive function, and the second one is this one. So thank you very much for joining me here. This is the Laplace transform of e to the power negative at. Stay tuned. This is Daniel. Please subscribe to this work if you haven't, and I'll see you in my next video.